Hello everyone. So now I will solve a simple problem on the curvilinear motion. So the problem statement is as so we have the box that moves in a conveyor belt with the acceleration given as 0.2 meters per second squared, and this one is, by the way, a tangential acceleration. The question says that to determine the time needed for the box to reach the point B, this is the point B, and the magnitude of this acceleration when it reaches the point B. And then, as you can see here, the problem has two parts. The first part is from this point to that point. Here there is no normal acceleration. The reason that, as I told in the first video recording or video, the radius tends to infinity, and therefore v squared by rho tends to 0. Therefore, we need to analyze the problem from A to, let me call this portion as C, from A to C and then C to B. And let's do that. So A to C, only AT, and then C to B we have AT and then AN. And then, let me check. We know that the acceleration is the change of velocity with respect to time. And then from A to C, I have the tangential acceleration, which is dv by dt. And this one is 0.2 times t, and that is dv by dt. And then from here, it follows that dv is 0.2 t and then dt. And the initial velocity is rest, therefore it is 0 when the time is 0. And then when the time is t, the velocity is v. And then from here it comes out that velocity is 0.2 t squared by 2 and then 0.1 t squared. Okay, but I need the distance relation so that I can find the time from A to C. So as I know that the change of the position with respect to time is the velocity, similar to acceleration, it will follow that is, so this one will be 0.1 t squared and then 0.1 t squared dt will be equal to ds. S is from 0 to 3 meters and t is from 0 to t. Okay, so if I solve it, then it will become that 0.1 t to the power of 3 divided by 3 is equal to, 3 times minus 0. So then it follows that t to the power of 3 is 9 by 0.1. And from here, 90. And then t will be equal to, okay, so if you calculate it, 90, let me see if there is a cubic. So then I will take this one and then to the power of 0.3333, and it makes 4.48 seconds. This is the time required to reach from A to C. And then I will look for the time to reach from C to B. And for this section, then CB section, this is point C and this is point B. if you look at it, it is a part of a circle. With the radius of r, and that is 1/4 of 2 pi r. So it will be that pi r by 2, and then the question says that r is 2, then it will be that 2 pi by 2, and then it is pi. Okay, and then since we have so this is the distance, let me add it. That is the s is pi here, so you know that the rest is here from A to C, and the distance is pi. And then similar to this one, in the previous case it was from 0 to 3, now it will be from, so I will just write the same relationship here, time is so it started from 4.48 to the time t, and then it goes from 0.1 t squared, that will be equal to, then the distance here was 3 meters, and then up to 3 plus pi, and then that's the ds. Okay, and then from here it follows that 0.1 t to the power of 3 divided by 3 from 4.48 time then the value to t, and that will be equal to 3 plus pi minus 3, and that will be just the pi. And then for this one, let's do the calculation. I will add one more slide. Okay, so it will be that 0.1 t to the power of 3 divided by 3 minus 0.1 times 4.48 to the power of 3, and then divided by 3, and then that will be equal to pi. Okay, then let's calculate the second part. This is 90 divided by 3, 30 times 0.1, and then 3. So it will be that 0.1 t to the power of 3 divided by 3 will be equal to 3.14 plus 3 meters, and then it will be that t to the power of 3 will be equal to 6.14 times 3 divided by 0.1, and then square, the third power of it, that will be 5.69, let's see. So the value was 142.2, and then time is 5.69 seconds. Okay, so you can solve it much easily. So you can solve it like from 0 to any time t of, so this is alternative, yes, alternative, 0 to t, 0.1 half t squared is equal to that you will have the ds from 0 to 3 plus pi. So this one is that take whole path. And then if you do this calculation, you will get the same result as this one. Okay, so now the question says that the magnitude of acceleration is when it reaches at this point. So I will continue this one in the next recording.